Now that we know the power rule, and we saw that in the last video, that the derivative with respect to x of x to the n is going to be equal to n times x to the n minus 1 for n not equal 0, I thought I would expose you to a few more rules or concepts or properties of derivatives that essentially will allow us to take the derivative of any polynomial. So this is powerful stuff going on. So the first thing I want to think about is why this little special case for n not equaling 0. What happens if n equals 0? So let's just think of the situation. Let's try to take the derivative with respect to x of x to the 0 power. Well, what is x to the 0 power going to be? Well, and we can assume that x for this case right over here is not equal to 0. 0 to the 0, weird things happen at that point. But if x does not equal 0, what is x to the 0 power going to be? Well, this is the same thing as the derivative with respect to x of 1. X to the 0 power is just going to be 1. And so what is the derivative with respect to x of 1? And to answer that question, I'll just graph it. I'll just graph f of x equals 1. To make it a little bit clear. So that's my y-axis. This is my x-axis. And let me graph y equals 1, or f of x equals 1. So that's 1 right over there. F of x equals 1 is just a horizontal line. So that right over there is the graph y is equal to f of x, which is equal to 1. Now, remember, the derivative, one way to conceptualize it, is just the slope of the tangent line at any point. So what is the slope of the tangent line at this point? And actually, what's the slope at every point? Well, this is a line, so the slope doesn't change. It has a constant slope, and it's a completely horizontal line. It has a slope of 0. So the slope at every point over here, slope is going to be equal to 0. So the slope of this line at any point is just going to be equal to 0. And that's actually going to be true for any constant. The derivative, if I had a function, let's say I had f of x is equal to 3. Let's say that that's y is equal to 3. What's the derivative of y with respect to x going to be equal to? And I'm intentionally showing you all the different ways of the notation for derivatives. So what's the derivative of y with respect to x? It can also be written as y prime. What's that going to be equal to? Well, it's the slope at any given point. And you see that no matter what x you're looking at, the slope here is going to be 0. So it's going to be 0. So it's not just x to the 0. If you take the derivative of any constant, you're going to get 0. So let me write that. Derivative with respect to x of any constant. So let's say that of a, where this is just a constant, where this is just going to be a constant, that's going to be equal to 0. So pretty straightforward idea. Now let's explore a few more properties. Let's say I want to take the derivative with respect to x of, well, let's use the same a. Let's say I have some constant times some function, Well, derivatives work out quite well. You can actually take this little scalar multiplier, this little constant, and take it out of the derivative. This is going to be equal to a. It's going to be equal to a. I didn't want to do that in magenta color. It's going to be equal to a times the derivative of f of x. A times the derivative of f of x. That blue color. Of f of x. And the other way to denote the derivative of f of x is to just say that this is the same thing. This is equal to a times this thing right over here is the exact same thing as f prime of x. Now, this might all look like really fancy notation, but I think if I gave you an example, it might make some sense. So what about if I were to ask you the derivative with respect to x, of 2 times x to the 5th power? Well, this property that I just articulated says, well, this is going to be the same thing as 2 times the derivative. This is going to be the same thing as 2 times the derivative of x to the 5th. 2 times the derivative with respect to x of x to the 5th. Essentially, I could just take this scalar multiplier and put it in front of the derivative. So this right here, this is the derivative with respect to x of x to the 5th. And we know how to do that using the power rule. This is going to be equal to 2 times, let me write that. I want to keep it consistent with the colors. This is going to be 2 times derivative of x to the 5th. Well, the power rule tells us n is 5. It's going to be 5x to the 5 minus 1, or 5x to the 4th power. So it's going to be 5x to the 4th power, which is going to be equal to 2 times 5 is 10, x to the 4th. So 2x to the 5th, you can literally just say, okay, the power rule tells me the derivative of that is 5x to the 4th. 5 times 2 is 10. So that simplifies our life a good bit. We can now, using the power rule and this one property, take the derivative of anything that takes the form ax to the n power. Now let's think about another very useful derivative property. And these don't just apply to the power rule. They apply to any derivative, but they are especially useful for the power rule because it allows us to construct polynomials and take the derivatives of them. But if I were to take the derivative of the sum of two functions, so the derivative of, let's say, one function is f of x, and then the other function is g of x, it's lucky for us that this ends up being the same thing as the derivative of f of x plus the derivative of g of x. So this is the same thing as f. Actually, let me use that derivative operator just to make it clear. It's the same thing as the derivative with respect to x of f of x plus the derivative with respect to x of g of x. So we put f of x right over here and put g of x right over there. And so with the other notation, we can say this is going to be the same thing. The derivative with respect to x of f of x we can write as f prime of x. And the derivative with respect to x of g of x we can write as g prime of x. Now, once again, this might look like kind of fancy notation to you, but when you see an example, it'll make it pretty clear. If I want to take the derivative with respect to x of, let's say, x to the 3rd power plus x to the negative 4 power, this just tells us that the derivative of the sum is just the sum of the derivatives. So we can take the derivative of this term using the power rule. So it's going to be 3x squared. And to that, we can add the derivative of this thing right over here. So it's going to be plus, that's a different shade of blue, plus, and over here is negative 4. So it's plus negative 4 plus negative 4 times x to the negative 4 minus 1, or x to the negative 5 power. So we have, and I could just simplify a little bit, this is going to be equal to 3. This is going to be equal to 3x squared minus 4x to the negative 5. And so now we have all the tools we need in our toolkit to essentially take the derivative of any polynomial. So let's give ourselves a little practice there. So let's say that I have, and I'll do it in white. Let's say that f of x is equal to 2x to the 3rd power minus 7x squared plus 3x minus 100. What is f prime of x? What is the derivative of f with respect to x going to be? Well, we can use the properties that we just said. The derivative of this is just going to be 2 times the derivative of x to the 3rd. Derivative of x to the 3rd is going to be 3x squared. So this is going to be 2 times 3x squared. What's the derivative of negative 7x squared going to be? Well, it's just going to be negative 7 times the derivative of x squared, which is 2x. 2x. What is the derivative of 3x going to be? Well, it's just going to be 3 times the derivative of x, or 3 times the derivative of x to the 1st. The derivative of x to the 1st is just 1. So this is just going to be plus 3 times, we could say 1x to the 0, but that's just 1. And then finally, what's the derivative of a constant going to be? Let me do that in a different color. What's the derivative of a constant going to be? Well, we covered that at the beginning of this video. The derivative of any constant is just going to be 0. So plus 0. And so now we are ready to simplify. The derivative of f is going to be 2 times 3x squared is just 6x squared. Negative 7 times 2x is negative 14x plus 3, and we don't have to write the 0 there. And we're done. We now have all the properties in our tool belt to find the derivative of any polynomial, and actually things that even go beyond polynomials.